When Sunshine invited me to this event, I was pretty excited. I said, whoever turns down Sunshine, you know. And that actually gave me the idea behind using this format, which is actually publicly available. This template on Prezi. I said, Sunshine, let's give it to Sunshine. So as a beginning, I want to talk generally about, the management aspect of climate change. So in the morning, we kind of saw the science. We saw a bit about, the projections, where we're headed. Now we're going to talk more about, the policies, how those impact the projections that we saw earlier. So that's a bit about my background, what I do. I'm a teacher. That's what I tell people, and I do research as well. As an outline, I know we already saw something about the science at the beginning. I'll still take some time to kind of talk about the science, just to create the background and the scale, defining the scale of the problem. I'll talk about the fundamentals of the economics, so that when I start talking about the policy implications, we get to understand why those policy implications matter. And of course, I've been participating on the IPCC report, which has been a fantastic opportunity. It's taken me around the whole world, from New Zealand to Spain to Changwon City in Korea, and even to Africa in Addis Ababa. So it's been a great opportunity. But I want to talk specifically about the mitigation report that just came out with respect to these 4 key issues. And of course, I'll talk about the role of uncertainty, not the type of uncertainty we saw earlier, but more from the policy angle or policy perspective. So that's the outline. I kind of want to get started with this UNFCCC Article 2 proclamation, where they said the ultimate objective of this convention and any related legal documents are stabilization of greenhouse gas concentrations in the atmosphere at a level that will prevent dangerous anthropogenic interference with the climate system, and to such a point that we want to achieve this stabilization within a given time frame, sufficient to allow ecosystems. Most importantly, I should have put this in pink or red, because we're trying to ensure that food production is not threatened, economic development is not stifled, and at the same time, we want to make sure that we develop in a sustainable manner. So that's the kind of, the overarching objective of the IPCC objectives. Currently, across the world, what we see here are emissions based on country levels. So it's kind of a fallacy when people tend to say, oh, the US is the highest emitter in the world today. Believe it or not, it's China, and then we have the rest of the world. Now, what I try to project here is that we're not saying China should not develop, neither are we saying India should remain undeveloped, but instead, their development should be towards sustainable paths. And how do we achieve or arrive at those paths? We saw this chart earlier. Again, this is just to show the breakdown of where we were and where we are headed in terms of the projections. So if you look at this chart, it shows carbon emissions by fossil fuel technologies and mainly by forestry and other land uses, constituting almost 80% of total emissions. So when I start focusing on industrial processes, especially the production of electricity, which is highly fossil fuel intensive, you see the reason behind that focus projected by this chart. Now, given that, how does this kind of, get divided across the sectors? So like here we have electricity and heat production accounting for 25%, which is the reason why we're focusing on that. And of course, there are other contributors. You have, land use, forestation, agriculture, 24%. You have buildings, transport, industry, and what have you. And you have the breakdown by indirect carbon emissions from these resources. The interesting thing about this result here that we're looking at is that some of the policies that I'll be talking about later, they are not limited to just electricity production. They are also applicable to industrial processes. Okay, so given that background, what does the science say? The objective of this slide is to tell us that climate change is a global problem, okay? It's global in the sense that we're contributing to the causes, and it doesn't matter where the contribution is taking place, the effect is overall across the globe. In addition to that is that the effects vary from place to place. not only do they vary from place to place, there's also the consequence that, the people that are going to experience more of the consequences are not even here today. They are future generations. So it's important to understand that current concentration of GHG, that's greenhouse gases, is approximately 450 parts per million of carbon dioxide equivalent, with an estimated increase of 2% per year over the next decade and centuries. So what makes this problem more kind of, challenging is that the carbon dioxide that are emitted, they tend to stay in the atmosphere for long periods of time, and that accumulation over time is what threatens future generations. So we have that as the science. In terms of where we are globally, here you can see we have the developed world, the world in general in red. If we do nothing, there's a tendency that we grow in that direction, which is just maybe a kind of a forecast or a projection into the future. Now we break that down into component parts of the world. So we have the developed world, who actually are doing a lot as we speak, and we have the developing world. I just showed a chart that shows China actually increasing in its consumption of these fossil fuel technologies. Given the outcome of what science is telling us, what does the underlying economics, what does it say? In order to discuss the underlying economics, we have to identify that this is a problem of negative externality. In other words, a producer that produces electricity is not actually paying the full cost of their production. In other words, we're not accounting for the damages that are due to the byproduct of electricity. In other words, right now, we're looking at private costs due to the generation of some of these negative externalities, but we're saying that if we can actually capture the social costs which are due to the damages, not only are we going to reduce our consumption, but also we're going to pay more for what we consume. So right now, the situation is more along the path of we're consuming so much at a very low price. But we're saying that the socially acceptable level is to consume less and pay a bit more. So we have the difference in price in terms of what we're doing and the consequence with respect to the environment. And that overall drives the economy or the economics behind climate change. It's a problem of negative externalities. It's global. Like I said earlier, the most affected are future generations, and they are not even represented right now. Long-term horizons, and there are lots of major uncertainties that are woven into the decisions that firms and individuals make. So this is a complex problem. It's complex because it's not only international, it's multidimensional, it involves growth and development, it informs innovation, technological change, demography and migration, and the incidences of climate change may lead to more of people migrating away from those regions where the calamities or catastrophes are of increased proportion. And of course, it is also a problem of ethical ethical dimension in terms of equity and fairness, because when you look at the causes or the people responsible for this pollution today, they are more on the side of the developed part of the world. Those that are experiencing more of the catastrophes or more of the damages are those in the developing part of the world. So that kind of gives, so what are the policy approaches? To talk about the policy approaches, again, I would like to show the decadal change in emissions over the last 3-4 centuries. So here you have between 1971 and 1980, we see the decadal change in emissions that's over a period of 10 years. Here we see that the result I really want to project out of this is to show that the blue bar, which shows the proportion of population with respect to the contribution to emissions, you see the blue bar has kind of stayed relatively stable, constant. But when you look at the deep blue bar, the GDP per capita, that shows that it's actually our economic activities, okay, human actions that are responsible, contributing more to the decadal change in emissions. Not only are those contributing more, over the last 3-4 decades, the rate of increase has actually skyrocketed, meaning that we seem to be doing a lot in terms of all those reports, but in terms of action, we're not doing much or as much as is expected. Well, the overarching objective is to move from this world where we're consuming so much of fossil fuel to a world that we are using just solar panels, we have windmills, hydrothermal, geothermal, and what have you, resources. How do we get from that world to that world? That's the solution strategies that we want to encourage. So from this current report, these are the main highlights. They are, one, we want international action, and I'll still go deeper into each of this. Mitigation approaches with respect to instruments creating market penalties for greenhouse gas emissions, like cap and trade systems, carbon taxes, new fuel economy standards, investments or instruments promoting technological research and development, energy efficiency and behavioral change, and of course, adaptability and vulnerability reduction. So in terms of international cooperation, it again goes back to the UNFCCC Convention, which is the main multilateral forum with nearly universal participation. Currently, there are other sub-regional bodies or some regional collaborations and cooperations going on that have different focus or different agenda with respect to how we should address this problem. But cooperation arrangements vary. They vary across each of these regional bodies because of issues of coordination and centralization. The UNFCCC activities since 2007 have led to an increasing number of institutions. So you have the UNFCCC, an organ of the UN, creating the need for international collaboration. And then out of that initial creation, you have other sub-entities. The policy linkages among regional, national, and subnational climate policies offer potential for mitigation and adaptation strategies. The potentials that are offered are not equilateral. They are not even across those different subunits that have been formed. And there are various initiatives that are either being developed, and I'm going to discuss about a few of those in a few seconds. In terms of technology policy, there are two levers. One is technology push. In other words, we're talking about publicly funded R&D, and the other one is demand pull in terms of the procurement by the agencies of the federal parastatals that we have across the different states. Such policies address market failures related to innovation and technology diffusion. But the problem with these policies, and which is the reason why we tend to have this political tension across divides, even here in the US, is because of the cost effectiveness of those policies. We keep throwing money down the drain, and people are like, of what essence would we make such investments? Within appropriate enabling environments, the private and public sectors should come together. Now, the reason we have these two levers, again, is going to be highlighted when I talk about the role of uncertainty. Energy efficiency, the growth in energy demand is actually one of the reasons that emissions keep increasing. So the question is, if we can address the source of emissions, maybe we can actually pen or kind of put a lid on our emissions. In other words, if we reduce our consumption by switching off the lights, having energy efficient buildings, installing energy efficient appliances in the homes and what have you, we may be reducing consumption. So those are strategies, and you can see in the chart I'm going to present in a few seconds, it shows that energy efficiency is very key to achieving the stabilization scenario or stabilization goals that we want to achieve. The cap and trade system, again, in the European Union, which is a regional body now, they have this EU ETS, which is the emission trading system, where countries participate. They kind of give a quota. Based on the quota, countries or states, firms in countries that need more emissions tend to trade and buy from those firms that don't need as much as they have been allocated. In the US, we have the Regional Greenhouse Gas Initiative, which operates in a similar manner or fashion as the European Union emission trading system. And there are plans in place to actually replicate this type of system across the Western states. Currently in the US, there are state policies that target more of renewable production in terms of what firms use in producing their outputs, especially electricity. So here we're showing the map of the US with several states showing what we call renewable portfolio standards. So for example, California is saying that we want to have 33% of our output from a renewable resource by year 2020. Okay, so with mandating firms that produce electricity, for instance, to have their output production from. Now, satisfying this requirement is not meaning or does not mean that you have to install or build a power plant that produces electricity from renewable. You may satisfy this requirement by buying what we call renewable energy certificates, which is a tool that is used to make this, to meet the target that is stipulated here. The carbon tax, which not many people want to hear about, it has the advantage that it's direct, it's straightforward, it's easy to understand. The more you pollute, the more you pay in terms of taxes. Revenue generated can be used to reduce other taxes, but of course, the carbon tax also comes with discretionary influences or discretionary output with respect to the distortions that it causes. So investments. Investments, basically, we're looking at total electricity generation with respect to renewables, nuclear, power plants with carbon capture and sequestration, fossil fuel power plants with no carbon capture and sequestration, extraction. What you see here is that the IPCC is forecasting that in the near future, we're going to have reductions in investment in those technologies that are fossil fuel based. And if we have to invest in technologies that use fossil fuels, then they have to be retrofitted with carbon capture and sequestration technologies. And right here is energy efficiency, which I said earlier is what we have to invest more into in order to actually reduce consumption with respect to the demand levels. So what's the scope of the response? The scope of the response is to cut global emissions by a factor close to 2.5. That's about a 40% reduction by 2050. In other words, as world output grows by a factor of 3, emissions must be reduced by a factor of about 7.45. We'll require strong action in all regions of the world. It's not a rich country problem, neither is it a developing country problem. Earlier, somebody asked about the role of developing countries in this process. In this current report, there was a mandatory requirement that every chapter, about 16 chapters, must contain a box on least developed countries, just to show that we don't want to treat developing countries as an appendage separated in a particular chapter, but instead as an intrinsic part of the entire report. Because if you look at the ethical requirements, it just makes sense to have that. So we're looking at a new energy industrial revolution where we're trying to transition to low carbon growth, which is an attractive path. We're trying to stimulate dynamic, innovative growth with large growing markets for the pioneers. In other words, we want to make sure that those that don't get on the boat early are penalized at the later stages. So early investment is key. What are the effects of some of these responses? Again, this is a McKinsey report that shows that energy efficiency will lead us from a business as usual path by a reduction of about 14%. If we include low carbon energy supply, regardless of the sources, we're looking at an additional 12% reduction. Terrestrial carbon, forestry and agriculture, that's the Afolu region, another 12%, and so on. So we're showing here that just a menu or a mixture of some of these policies could begin to show in terms of the future path of these emissions. This, again, kind of accentuates the result. Here we have the baseline with respect to change from 2005 with respect to 2050. So here you see the baseline scenario, this is where we are. If we have stringent climate policy, that's the focus, or that's the destination. And here for sulfur dioxide, we have a similar relationship. Okay, and here is a taxonomy of decision making. So some of these charts you're seeing, there are things that you're going to see in the final report. This came from my chapter, chapter 2, Integrated Risk and Uncertainty Assessment of Climate Change Response Policies. Here we're showing a taxonomy of decision making. So horizontally, we're showing the scale or the level of decision making at the international level, national government, local industrial firm, and right down here you have the household or individual level. Now, you'll be surprised that many of these decisions are also a function of how wealthy or how poor a country is. For many of the poor countries, the decisions are at this level, and for many of the rich nations, they are more of at the national or government level. So what are the policies? Long-term targets, transition pathway, policy instrument, resource allocation, lifestyle, and behavior. So what we have in these circles are the locus of uncertainty with respect to the decisions that have to be made. So here you have climate responses and associated impacts intersecting both long-term targets and the pathway to get to those targets. Here you have stocks and flows of carbon and greenhouse gases, technological systems, and so on and so forth. That's just a taxonomy of the decision-making that is to be encountered. So the elephant in the room, in this case, is uncertainty. In my own research, we actually came up with this observation that when you increase uncertainty, what you see with respect to this pie is that the volume or the size of the pie is shrinking, which is just a classic response to decision-making under uncertainty. When you're uncertain, you tend to want to hold back your investment until you are sure of what the future policy is going to be. So here we show increases in risk with respect to policy uncertainty. What does it imply in the context of the report that is just coming out? It shows that with respect to different instruments, allowance trading market, renewable quotas, subsidies and feed-in tariffs, in most cases, uncertainties along these instruments always dampens investment. It always does dampen investment. And given the incidence or the observation of uncertainty, this is just to summarize that policy is always influenced by risk and uncertainty, which is why national bodies or national countries are trying to stay back in terms of going after real stringent measures to reduce emissions or reduce consumption patterns. So what are the key points? Climate change response involves both mitigation and adaptation. I haven't spoken much about adaptation here because this report is specifically on mitigation. But then it's not like we dampen mitigation at the expense of the other or we promote one. Instead, both should go together. It's all about managing the unavoidable and avoiding the manageable. This quote actually comes from Hogan, Bill Hogan, who says that in order to avoid this future catastrophes that we're looking at, we have to manage the unavoidable, which we're already experiencing. Someone asked earlier today about, we've been having cold, it's not warm. Well, climate change is not about warm or global warming, it's about the variability, which was captured by Chris earlier in terms of the distribution on the changes in the weather patterns. So here we're trying to manage the unavoidable, and we're indirectly trying to avoid the unmanageable when those catastrophic events happen in future. Basically, policies are interwoven with low carbon growth and development, tax policies aimed at reducing greenhouse gas emissions, along with technology policies, have helped to weaken the link. So there's always this talk out there that, if we implement tax policies, we're not going to develop, we're not going to grow, forgetting that the fossil-based technologies that we so much rely on today had a lot of government support in the first half a century of their enactment. Do you believe that in 1903, less than 3% of homes in America actually have access to electricity? But today, what are we talking about? So the point is that in terms of future policies or even current policies, we should look at how we can empower some of these renewable technologies and give them what will make them compete. And they're already competing. Today, the cost of solar has reduced by more than half within a 5-year period. We're talking about generating electricity on your rooftop and even selling back to the grid today. So these are just some of the points that resonated out of the report that we put together, and I'll be happy to take your questions.